Welcome to the DIY Honda Garage channel. The DTC, or Diagnostic Trouble Code P2245, indicates a problem specifically related to the rear air fuel A-fill sensor, which is situated on Bank 1, Sensor 1. This sensor plays a critical role in measuring the air-fuel mixture going into the engine, ensuring optimal combustion. The code points to a low-voltage condition in the VCENT circuit, which refers to the voltage reference for the A-fill sensor. This type of issue can impact engine performance, emissions, and fuel efficiency. Understanding the components involved is crucial for pinpointing the problem effectively. In the Honda Odyssey, the location of this sensor can often be found along the exhaust path before the catalytic converter. Ensure to gather all necessary diagnostic information before proceeding with troubleshooting steps as outlined in the manual. The rear AFAC sensor, specifically for Bank 1, is essential for optimal engine performance as it measures the air-fuel ratio before it enters the catalytic converter. This data is relayed to the Engine Control Module, ECM, which adjusts the fuel injectors for achieving an ideal combustion mix. The VCENT circuit ensures that the sensor receives the correct voltage signal, which is vital for its operation. When diagnosed with DTC P2245, it usually points to a low voltage in this circuit, indicating a possible open or short circuit, faulty sensor, or issues with the wiring. The sensor is located in the exhaust system, typically downstream of the engine, but upstream of the catalytic converter, making it susceptible to heat and vibrations that can cause wear over time. Several factors can lead to the activation of DTC P2245. A short circuit within the wiring connected to the A-F sensor could disrupt the normal voltage flow, causing the signal to drop below expected levels. Furthermore, the A-F sensor itself may be malfunctioning due to wear or damage, rendering it unable to provide accurate readings. Lastly, issues with the Powertrain Control Module, PCM, could also lead to this code. If the PCM fails to interpret the sensor's data correctly, it might mistakenly report low voltage as a fault. Each of these components plays a significant role in the system, and troubleshooting should focus on identifying the exact cause through proper diagnostic methods. When DTC P2245 is triggered, several symptoms may manifest, negatively affecting the vehicle's overall performance. One of the most noticeable symptoms is engine performance issues, such as poor acceleration or rough idling. Since the AFAC sensor plays a pivotal role in regulating the air-fuel mixture, its failure can disrupt the combustion process, leading to a decrease in efficiency. Additionally, drivers may observe noticeably poor fuel efficiency as the engine struggles to maintain optimal combustion parameters. Increased emissions are another significant concern. If the engine burns too much fuel, it will produce more pollutants, potentially leading to failed emissions tests. To begin the troubleshooting process for DTC P2245, first ensure that the ignition switch is turned to the on, to position. This action powers the vehicle's electronic systems without starting the engine. Next, utilize the Honda Diagnostic System, HDS, to clear any current diagnostic trouble codes that may be previously stored in the system. After clearing codes, start the engine and hold the RPM at 3000 without load, either in park or neutral, until the radiator fan activates. This step is crucial because it allows the engine control module to undergo a complete analysis of sensor data under simulated driving conditions, setting you up for assessing whether the DTC recurs. After performing the previous step, the next task is to check for any pending or confirmed diagnostic trouble codes using the HDS. At this stage, it is essential to see if DTC P2245 or any related codes are present in the system. If the DTC appears, it indicates that the problem persists and you must proceed with further troubleshooting. However, if no DTCs are present, this may suggest an intermittent failure. In such cases, the system may be operating correctly at that moment, prompting you to inspect potential issues like poor electrical connections or loose terminals associated with the AF sensor or the PCM. Properly securing these connections can often resolve underlying issues. To continue diagnosing the issue, turn the ignition switch to the lock 0 position, ensuring the vehicle is completely powered down. Next, jump the SCS service check signal line using the HDS. This action enables the service mode for further diagnostics. Following this, disconnect the 6P connector from the AF sensor to isolate it from the vehicle's electrical system. This disconnection allows you to examine the sensor and associated wiring more effectively, ensuring you can measure voltage directly from the component without interference from other circuits or electronic signals around it. Next, disconnect the PCM connector B, which features 49 pins, to access critical terminals necessary for testing. Once disconnected, check for continuity between the specific PCM connector terminal B15 and body ground. This check is crucial as it assesses whether the VCENT circuit is receiving a proper ground signal. If you find continuity, it suggests that the wiring is intact from the PCM to the AF sensor, indicating a possible short circuit elsewhere in the wiring harness. If continuity is absent, this indicates an issue that must be addressed, as it confirms that the signal path is broken somewhere along the line. After evaluating continuity and making necessary adjustments or repairs, the next step is to reconnect the PCM connector B to restore the electrical circuit. Following the reconnection, start the engine and once again, hold the RPM steady at 3000 until the radiator fan engages. This allows the system to stabilize under load conditions. Measure the voltage at the AF sensor's 6P connector terminal number 4, relative to body ground. This measurement is vital, as it directly indicates if the sensor is receiving the correct voltage from the VCENT circuit. If the voltage readings are within specifications, the AF sensor may be functioning correctly. If not, further investigation will be warranted. Once you have completed the repair steps based on your diagnostic findings, it is crucial to conduct a final verification process to ensure that everything is functioning as intended. First, confirm that the AF sensor operates correctly by checking its response to changes in engine conditions. Next, recheck for any diagnostic trouble codes using the HDS to ensure that no new codes have appeared since your repairs were completed. Finally, a test drive of the vehicle is essential to validate that the issue does not return under normal driving conditions. This comprehensive approach ensures that you address all aspects of the problem and guarantees that the vehicle is operating reliably and efficiently. Ensure a proper maintenance schedule is adhered to in order to prevent future occurrences of DTC P2245 and related errors. Regularly inspect AF sensors as part of routine maintenance to catch any early signs of wear or damage before they cause significant issues. Pay particular attention to the connectors and wiring. Corrosion or loose terminals can lead to erroneous voltage readings and must be addressed promptly. Additionally, regularly monitoring the vehicle's coolant levels is essential for ensuring that the engine operates at optimal temperatures, which can further prolong the life of the sensors and other components. Preventive maintenance can save time, money, and enhance vehicle performance. In summary, understanding the role of the AF sensor in your Honda Odyssey is vital for diagnosing and resolving DTC P2245 issues. Following the outlined troubleshooting steps can systematically uncover why a low-voltage condition exists in the VCENT circuit. Proper diagnosis involves checking for wiring shorts, sensor malfunctions, and ensuring the PCM is operating correctly. Additionally, regular preventive maintenance practices can considerably lower the chances of future problems, ultimately enhancing vehicle reliability and performance. By staying proactive, you can facilitate the smooth operation of your Odyssey and ensure its longevity. Please like and subscribe to the channel. See you next time.